what I'm going to talk about is how Cloudflare uses ClickHouse to scale, and I'm going to define all those things a bit more. But first of all, let me add like one of many disclaimers really, which is, well, I saw this video on YouTube with a famous chef, Daniel Boulou. He's a famous French chef. He has a restaurant in New York called Daniel, and he's cooking steak au poivre. And he's saying, you know, there's a lot of theories about how to cook a steak. This is my theory. Good luck. So, I mean, I really appreciate like the good luck part. So this is my theory about scaling and how you should think about scaling. It's not the only theory. I hope you find it useful. Okay, there's also a demo I forgot to mention. So I'm going to try to get through the slides quick so I can get to the demo. But first I need to define some things. So what is ClickHouse? This is like, presumably you know what ClickHouse is or you wouldn't be here. But it's important to say, like, we at Cloudflare, we use the open source ClickHouse project, which is why I was able to say 7 years. That's 7 years for me. Almost 10 years at Cloudflare, we've been using ClickHouse. And so we use an open source version exclusively. There are other ways to run ClickHouse. So remember what my talk is about, like how do you scale with, one way you could scale would be to consider the ClickHouse cloud. And they would provide a great service, very scalable. I think I've heard it's great. We don't use that, so that's not what I'm talking about. What is Cloudflare? Does everybody know what Cloudflare is? Raise your, like, do you all use Cloud? I mean, I feel like anyone who doesn't know what Cloudflare is, this is probably the biggest thing that you've never heard of, because Cloudflare is actually huge. We serve different aspects of the internet, a large percentage of the internet. We have some great tools, developer platform that I wish you would check out. A lot on offer. And so when you were saying, like, how do you scale something? Another good idea would be to use Cloudflare because, you know, like a DOS attack can affect anyone. So what is trouble? So what I'm talking about trouble is basically all the things that most of us here in this room probably have experienced. If you carry a pager, you know what I'm talking about. So things fail. Things fail all the time. As you go up in scale, things are going to fail more frequently. Basically, you can assume like something is always broken somewhere. So when I'm talking about trouble, I'm just talking about like in generic terms, things will go wrong. You can count on it. And then when I talk about what is scaling, in my mind, scaling is a process and not a state you can be in. Like, you know, you say like, well, if we reach 1 million events a second, we've scaled. Well, actually, like that's an important milestone on the overall journey of scaling. It's all about going from one thing to another. This chart I'm showing, like, you know, like up and to the right, this is not made up. I kind of obfuscated it without showing you the units, but this is my experience at Cloudflare. So when I joined Cloudflare 7 years ago, it was by far the biggest event pipeline I'd ever seen in my career. That's way off to the left. You know, like this is where it is today. So when we're talking about scaling, it's not a process that ends, I think. It's a process that continues. And so there's always more. So I'm trying to relate this whole idea of scale with this idea of trouble. You could say, like, suppose our load doubles. Suppose, you know, we get this many more visitors. We have to scale up. So you can think of trouble or problems as like an unexpected high frequency scale down, right? So if you lose half your capacity, it's kind of the same thing as doubling the load, right? So the trick for us as designers and engineers is to figure out like how can we deal with that in a way that's helpful or that doesn't necessarily fail completely. Okay, so now I have a demo, and I'm going to do this. So the first thing is to connect to ClickHouse. Can everybody see that? Is it too small? Okay, so here's one of many caveats that I'm going to give you. Disclaimers, really, is like I am not typing this. Okay, so like you saw I wave my hands a lot. This is not a live demo. But it is live in the sense that I did type this. So you'll see all my typing errors. I recorded it. Now, why would I do that? Well, because this is a live system that I'm showing you today. This is a live system at Cloudflare that I do have access to, and I'm not willing to do that live. Like we don't have enough. Cloudflare is a very efficient company. We run very lean. We don't have enough spare capacity that I can create a demo system at the scale that I would really like to show you. So I just use the live system. And this contains customer information. It contains real information. I'm not willing to take a chance that I might, expose something or screw up or delete it. I don't know. I can't. So I recorded it. It's like live on tape from Hollywood. Like pretend that it's live. That's the first disclaimer. Now, what is the query I ran? I ran a query to count this. This is part of the system tables. You can get this errors count from a cluster. So this is a really big cluster, by the way. And you can see there are no errors. That's cool. This is not the way we do it in real life. We have lots of telemetry and metrics. But it's cool because it's within ClickHouse, and I can just get this count. So I'm just doing that to set the stage. Everything is working normally. Now, here is a view that I made for the purpose of the demo. So what this is, I'm going to try. One thing I will do live is see if I can make this bigger. OK, so this is obfuscated. The table stack behind this view actually has 65, 70 columns. It has a bunch of real data. What I did is I created a view to kind of obfuscate it, but it's still like, trust me, it's like a real data set. And so there's a timestamp. Obviously, we always have a time series. And then there's a counter and a float value, and then this thing called namespace ID, which I'll explain in a minute. OK, so now I'm going to query some data out of there. And you'll see like what this query is it's getting a sum and a count and some quantiles, OK, for this data for 1 hour. OK, so there's 96 trillion events in that 1 hour for this table stack. And then this last thing I kind of have to explain. It says MOE. What that is short for is margin of error. OK, so we have a way of calculating using some estimators and a confidence interval how accurate these results are within a margin of error. So this is a percentage essentially. So that's 0.6%, plus or minus 0.6% for 96 trillion for 1 hour. OK, so then I get to do this thing where I zoom out for a day. What is it a day? 1.61 quadrillion. I don't know how, like, not many people get to say quadrillion. So this is like a vanity thing for me, where I get to say the word quadrillion, 1.61 quadrillion events per day, OK, for this thing. But I'm going to do something extra here where I'm going to go, and you'll see there's a thing in there called namespace. And what I was showing you before was like a zoom out, a whole bunch of namespaces combined. So this is one that I know. So I selected a namespace, and this is data which I know what it is. I'm not going to tell you what it is, but this is data I know what it is. So for namespace 93, 1 day is 263 billion events with a margin of error of 0.27. So this is better behaved data. And I can also explain that these quantiles are durations. So it's like something is 74 seconds. This is all cool. I think it's cool because that's actually a lot of events, OK? So now I'm going to go that tricked on me because I resized my terminal. But what I did is I just went to an hour because that's easier to look at. So roughly 16 billion events an hour in namespace 93, margin of error 0.1%, OK? Now I'm going to do the thing. And what I'm going to do is disconnect one of our main North American data centers from the internet. OK, so we have over 300 data centers around the world. We run ClickHouse in some of them. We have really big clusters. As you can see, they contain a lot of data. What I just did was to disconnect one of those that holds ClickHouse and part of that cluster. What's actually happening right now is that there's a split brain. There's some part of that that's still in that data center that's like doing whatever it does. But that's not what we're connected to. We're connected to the part that's still connected to the internet. And if I go back to ClickHouse now and run that query again, you'll see, okay, there are a bunch of errors. Now that, if I keep running this, this is just going to go up. It's going to produce more and more errors. But if I run that query I did with the MOE, you'll see like I get the same answer. I get the same answer with a relatively similar margin of error and in less than 1 second. So I think that's really cool, actually. And so the second disclaimer, I didn't really do that, okay? So I don't have the power to disconnect the data center and take it offline. That command I showed you is fake. But what's real is that I recorded this whole session while we were doing one of our regular cut tests to ensure the reliability of our system. And so that is real. That really happened. It just didn't happen just now when I pretended to type it. Okay? So that's really cool. So the next thing I'm going to do is I'm going to go back to this again and now disable all the ClickHouse data centers in all of North America. All right? So this is would be normally a very impactful event. So you figure like all of North America is now somehow disconnected from the internet. Our data centers that contain ClickHouse are relatively, I mean, we have a resilient cluster of them, but they are in one region, and that, I suppose that could happen. Now I just simulated that, and if I go back to ClickHouse again and run that query again, okay, so it still works, is the point. So it's not getting most of the, but the answer is still the same, right? So we're in a margin of error of less than 0.1. The reason why is because we designed this thing to deal with an event like that, and North America is not the only continent. So we have data centers in Europe as well, and now this is all coming from Europe. Now you could say the same thing, like, okay, well that's a lot to deal with, but if more data is the same thing as degraded system. Does that make sense? And so what I'm doing now is zooming out. So I'm saying, okay, I've been showing you an hour a day. Let's try it for a week. What do we get? So I get a big number, a bigger number, right? Because it's a whole week now. I still get a low margin of error. And if you look at that, that still took less than 2 seconds. All right? Now let's do a month. Same, right? Less than 2 seconds, low margin of error. I get the answer. How about a year? Same. I can run it for a whole year. It's less than 2 seconds. How many records am I looking at? 67 trillion. All right. Now, here's something interesting. If you were paying attention, you probably missed it. I wouldn't blame you. These numbers don't add up. So when I did a year, it wasn't 12 times a month. Why? Well, we can use ClickHouse to figure that out too. And so if I do group by month, you'll see, okay, like this number's going up. It goes up every month. And that's why they don't naively add up. So I can see all of that just in this one query. That's pretty cool. It's a lot of data to look at that quickly. This thing is scaling. And this is true like basically everything at Cloudflare. We're always scaling, like there's always more. There's always more tomorrow. But we've designed our system around ClickHouse to be able to deal with that. You can also see something interesting here. It looks like somebody changed something or fixed something because these quantiles, which show durations, they suddenly went way down. That's a good thing. I don't know why. I honestly don't know why. But this is, I think, interesting. So what did we just see? So we're resilient to a wide variety of potential failure modes, right? Because basically losing a drive is trivial compared to losing a whole data center. We've also made a system that's responsive. So no matter how much, whatever thing I'm asking it for, it will return in less than 2 seconds. Also, it's worth noting, like, these numbers are pretty high. So you may not have numbers this high, but I think the principle is the same. So what's so great about ClickHouse? And I think maybe this is the part that I like to talk about. So what's so great about ClickHouse? I think the community, we've gotten a lot over the years by being part of this community, all of you guys, I guess, having access to the source code. We use the open source. This is an underrated feature that I'm very thankful for, and you might want to think about, which is the HTTP protocol. So everything I showed you, all our clients, everything we're doing is with the HTTP protocol. Why? Well, HTTP is kind of universal, right? And so there are all these different tools and modes that you can leverage if you're just talking HTTP. The other great things about it is that there's minimal coordination required. So in other words, like, ClickHouse has this great thing where it's not going to have to do Raft or Paxos constantly all the time. So when I take a third of the capacity away, we did in the demo, not that much goes wrong, to be honest, because, like, all of those nodes are still there. A lot of the complexity in ClickHouse, I think, is optional. So if you can pick the layer that's right for your use case. That's what we've done, is try to leverage the things that work well for our specific use case. There's a lot of different features that you could turn on and off. And then what I'm calling soft clusters, what I mean by that is that, like, what is a cluster in ClickHouse, right? It's just, you can interrogate any node and ask for answers. You can kind of, like, pick combinations of nodes yourself. And so this gives us a lot of control and flexibility about how to find the nodes that are working and happy. And then I think it's fair to call out, I think the SQL dialect that ClickHouse has, I mean, at first, maybe it took a little while, but I really like it, and I think it's a surprising advantage. So if you're not familiar with the SQL dialect, like, dive in, because I think Alexi might have said the same thing. Like, I think it's really cool. It's worth calling out. That's it for me. I guess the last thing I should say is think about scaling now. I mean, it's never too early, it's never too late. You'll never be done. So depending on what your project is or your application, try it at 100 times. Like, what will happen? Suppose it suddenly scales 10x or 100x. What would happen? Will it fail in a good way, or will it fail in a bad way? And then the inverse of that is, like, what if you lose 9/10 of the capacity? What would happen? Would it just keel over, or would you be able to use it successfully? All right, thank you for your time. Do we have time for questions? Or should we go on to the next person?
So I guess my question is, with your flexible clusters, are you guys just not using Zookeeper or ClickHouse Keeper and just defining all of your nodes in the cluster definition and replicating other ways?
No, we use Zookeeper for replication. It's not replicating in that, it will have to catch up, but we also we run it with shards. So a shard replicates with its buddies, and then those will have to catch up, but the thing as a whole still is accessible. It's not a very clear answer. The answer is yes, we use Zookeeper.
So you're replicating. Would your demo have worked if you hadn't included that namespace ID on those queries?
Yes, it would have. But the truth is that margin of error number would have been higher, because that data, the variability of that data It's like all mixed up, and so the variance is really high.
So that ID is like a shard ID, basically. It's
No, that ID is like a specific metric of something that we're measuring, and I know what it is. It's super valuable, and it's measuring obviously something that's increasing over time.
How long does it take to index the ingested data and then, or to ingest the data and then index as well? Because I assume all the data that you just queried are pre-indexed.
Well, we use a merge tree, so like indexing and ingestion are synonymous.
Well, what about like just ingest? So all, like you could have run the query for like 1 minute, in the past 1 minute, and those would have been completely real time?
Well, there's some inevitable lag, right? But for any minute that's reasonable, that's true. It would be there.
Yeah, and do you know the latency between from the time the items were ingested to when merge tree made those items available?
No. So the way to measure that would be with quantiles. Like I think part of the answer, and why that's an interesting question, is that should be allowed to be flexible, because things are not going to be working optimally all the time. So like one lazy drive can increase that number for some subset of the data, but for not overall. So we should take that into account, but not fail because of it.